Hi everyone. Today our students will explain Rabin Karp algorithm in DT based. It is widely used string matching technique in data structure that helps in efficiently finding a pattern within a large body of text in many real world applications such as search engine, plagiarism detection system and DNA sequence analysis. Fast and accurate pattern searching is essential. Traditional approach like the navy string matching method compare each character one by one, which can be time consuming for large data sets. To overcome this limitation, the Rabin Karp algorithm uses a hashing technique that converts string into numerical values, allowing quick comparison by comparing hash values instead of entire string. The algorithm significantly reduces the number of direct comparison needed. This approach only improve efficiency but also demonstrate how mathematical concepts like hashing and modular arithmetic can be applied in data structure to solve practical problems.
The Rabin Karp algorithm is an efficient and string matching algorithm used in data structure to search for a pattern within a large text. It is widely applied in areas such as plagiarism detection, search engines, and bioinformatics. The need for such an algorithm arises because traditional methods like a name string matching approach compare each character individually, which becomes inefficient for large text. The Rabin Karp algorithm improves this by using a hashing technique to compare numerical values instead of strings. This reduces the number of comparisons and speed up the process. The algorithm was developed by Michael O. Rabin and Richard M. Karp, and it demonstrates how mathematical concepts can be used to solve computational problems effectively.
The Rabin Karp algorithm works based on the idea of hashing. It first converts the given pattern and a substring of the text into hash values using a hash function. Initially, the hash values of the pattern and the first window of the text are calculated. Then, the algorithm slides the window one character at a time across the text. Instead of recalculating the hash from scratch, it uses a rolling hash technique to update the hash value efficiently. This involves removing the contribution of the outgoing character and adding the new incoming character. Whenever the hash value of the text window matches the hash value of the pattern, a direct comparison is performed to verify the match, since different strings can sometimes have the same hash value.
Data structure concepts used. From a data structures perspective, the Rabin Karp algorithm mainly uses strings or arrays to store the text and pattern. It also uses integer variables to store hash values and constants such as base value and a modulus, typically a prime number, to compute hash values. The concept of hashing used in this algorithm is closely related to hash tables, where data is mapped using a hash function. Although hash tables are not directly implemented here, the same principle of transforming data into numerical form is applied. The efficiency of the algorithm depends on how well the hash function distributes values and minimizes the collisions which occur when different strings produce the same hash value.
Rabin Karp algorithm has different performance characteristics depending on the situation. In the best and average case, the time complexity is order of n, where n is the length of the text and m is the length of the pattern. This is because hash comparison are much faster than direct string comparisons. However, in the worst case, when many hash conditions occur, the algorithm may need to perform frequent direct comparisons, leading to a time complexity of order of n. Therefore, the choice of an effective hash function and modulus is very important to ensure good performance. Despite this limitation, the algorithm performs well in practical scenarios, especially when multiple patterns are involved.
The Rabin Karp algorithm has several advantages that makes it useful in real-world application. It is simple to understand and implement, and it is particularly efficient for multiple pattern matching. It is commonly used in plagiarism detection system, where large volumes of text needs to be compared, and in bioinformatics for matching DNA sequence. However, the main limitation of the algorithm is algorithm is the possibility of a hash collision, which can reduce efficiency by requiring additional comparisons. Even with the drawback, the Rabin Karp algorithm remains an important technique in data structures, showcasing how hashing and mathematical methods can be applied to solve complex problems efficiently.
We conclude that Rabin Karp algorithm is an effective and elegant solution for the problem of pattern matching in large text. By using hashing and a rolling hash technique, it reduces unnecessary comparison and achieve better performance in many scenarios, especially when multiple patterns need to be searched. Although the algorithm may face issues such as hash collision, which can slightly affect efficiency, it still perform well in most practical applications. Simplicity combined with its ability to handle large-scale data efficiently, making it an important concept in data structure and algorithms. Overall, the Rabin Karp algorithm highlights how combining data structure with mathematical techniques can lead to powerful and optimized solution in computer science. Thank you.